Hello everybody, in this video we're going to start to exploring what we will learn from chapter 6, the continual probability distribution. I know when you're looking at the discrete distribution, especially binomial distribution, after you watch the computer skill part, you might feel a little bit challenging because including the boundary or not including the boundary actually going to give you a different probability. Actually, in this part, chapter 6, when we look at the continual distribution, and you're actually going to notice that it's not that different. So for the continual distribution, such as normal distribution, with or without boundary, it doesn't matter. And the second I want to point out is that if you learn your statistic class before and maybe your professor mentioned that, is that how useful the normal distribution is. So we believe that as your sample size increasing large enough, everything going to become normal distribution. So that we do have the mathematical theory to support it. Therefore, the normal distribution is very, very important. And also in a few after we finish learning the probability, we're going to move on the regression analysis. So actually, we are assuming our data is following a normal distribution. Therefore, the normal distribution is very important. And I hope you take your whole heart learning this part. And after this video, you're actually going to learn how to use Excel to assist you to calculate the probability for the normal distribution. And so let's look at our slides together. So continual probability distribution. A continual random variable can be assumed any value in an interval of the real line or in a collection of intervals. It is not possible to talk about probability of the random variable, assume a particular value. Instead, we talk about probability of the random variable, assuming a value within a given interval. So how does that work? So this curve, I'm sure you see it many times. So this is called a normal distribution curve, right? So this is the probability density function. So the probability for x is measured by the size of the area under the curve. So for instance, the probability or the x larger than x1 or smaller equal to x2 equal to the blue shaded area. How that works. So first of all, the horizontal axis is my x value. So x value, and then we first find the value for x1, and then we find the value x2, and then we draw two vertical lines. So that would become the boundary of the area, and then the size of the area under the curve and between these two vertical lines, which is this blue area. So if we can calculate this, the size of this area, that's the value for the probability for x between x1 to x2. So one thing I want to emphasize is sometimes people will ask you, okay, x is follow a normal distribution. So what's the probability for x equal to x1? So if we deal with the binomial distribution, that is what we learned in last video. So then you can use BINOM, the DIST, and then you choose false, and then you will be able to get the probability, right? However, here we are dealing with the continual probability distribution. So then we have to go back to look at what I just explained, how you get the probability for x between x1 and x2. So that is you try to figure out the size of the area. Now look on this chart, x equal to x1. Basically, it is a vertical line, right? The size, I'm not talking about the length. I talk about the size of the area of a line is 0 because there is no area is corresponding to a line. So the line only have a length, but they don't cover any areas, right? So therefore, f x equal to x1, the probability for x equal to x1 equal to 0. The same, x equal to x2 is also equal to 0. So basically what I want to point out here is that if you deal with a continual distribution such as the normal distribution, the x equal to one value, exact value, always equal to 0. Always equal to 0. So why this is so important? Because if x equal to a value always equal to 0, so when you calculate the probability for this situation, x larger than equal to x1, smaller than equal to x2, and you will find this one is also equal to probability for x larger than x1 and smaller than x2, because with without equal sign doesn't matter because x equal to the boundary always equal to 0. So you're having the boundary or don't include the boundary, you won't change the probability. So that's something I want to point out because when we deal with the binomial distribution in the last video, you notice that with and without equal sign, you're actually going to get different numbers. But that's not the case here. The main reason is binomial distribution, it is a discrete random variable. So every boundary counts. But here, continual probability distribution deal with a continual probability distribution, a continual random variable. So x equal to a value is probably equal to 0. Okay, so this is something I want to emphasize. And so that's basically what I explained it. So now let's look at our normal distribution. So the normal probability distribution is the most important distribution for describing a continual random variable. It is widely used in statistical inference. So it has been used to measure the height, to representing the height of the people, test scores, rainfall amount, scientific measures. You notice that all those situations can be used a quantitative variable, the random variable, continual random variable to measure it. So we believe they are normally distributed. So now I will show you how the normal distribution look like. Again, similar as a binomial distribution, I don't want you to memorize how this formula look like. I only want you to identify the unique English letter on the right hand side because we're going to use Excel to help us to calculate probability. Yeah, but even use the Excel, you have to tell the certain values before the Excel can figure out the probability. So fx is the probability. On the right hand side, you will notice that we have the following unique English and Greek letter. So we have sigma, we have pi, we have e, we have x, we have mu. So we totally have 5 unique English and Greek letter. So the good thing is pi and e, they are constant. So the computer itself will figure it out. So they know because they never change from case to case. They are literally is a constant. So you don't need to tell the computer about these two values. However, mu representing the mean, sigma representing the standard deviation. So they are different because you are dealing with different cases. Different cases will have different mean and standard deviation. Therefore, later when we move on to the Excel, before you use Excel to calculate the probability for a certain case, after you read the case, you have to identify the value for mean and the value for the standard deviation, and then you plug in the Excel formula. Then it will give you the probability. Okay, so before we move on to the computer, I want to build out the rationale about what is computer are doing. So characteristic, what are the characteristics we have for the normal distribution? First of all, it is a symmetric. So you see this beautiful curve many, many times. And so it's a symmetric, and which means the skewness, this statistic always equal to 0. And second, when you talk about normal distribution, what you need to talk about is, okay, it's a normal distribution, and then you need to identify the value for mean and standard deviation, because mean and standard deviation like a fingerprint for your unique normal probability distribution. If mu or sigma are different, you will get different normal distribution. Therefore, mu and sigma are the fingerprint for your normal distribution. So what is mu and where will be represented on your probability density function curve? So the highest point on the normal curve is at the mean, which is also the median and the mode. So it's a little bit confusing when we look at chart. So the highest point, so here is not mean, median, mode. The mean, median, mode is on the value of your x-axis. So therefore, the value here is the mean, median, and the mode. Okay, it's corresponding to the highest point, so the peak. So after you find the peak and you draw a vertical line, so this intersection between vertical line and this horizontal axis. So here is the mean, median, and mode for your random variable of x. And so it depends on how x and the mu changes, and you will get a different curve, such as these 3 curves, sigma, the yellow, blue, and pink. So first of all, I want to talk about mu, as we already identified the value for mu, that is corresponding the location of the peak, right? So first of all, you find the peak for the pink curve and you draw a vertical line. So here is mu pink, that's called mu1. And then you find the peak of yellow and the blue. By coincidence, they actually, their vertical line will overlap each other. So basically, here will be the mu yellow, we use mu2. And also here is mu blue. So mu yellow equal to mu blue, because after we draw the vertical line, they overlap each other and ending up the same dot on the x-axis. But however, you can see the yellow and blue curve, they're different. The reason is because the sigma value are different. So sigma value different. So how the sigma value gonna affect in the shape of my normal distribution? So the sigma, the larger the sigma, making the curve flatter. So look at these three curves. So which curve is the flattest one? Yes, the pink one is the flattest one. Therefore, the mu pink, where sigma pink, we use sigma 1 to representative, has to be larger than the rest of two. So yellow and the blue. But yellow and the blue, they are different too. So which one is relatively flatter? Yes, the blue is relatively flatter. So therefore, it's larger than sigma 3. So we use sigma 3 to representing the blue. And then that is larger than sigma 2. So that's representing the yellow curve. So you can see we are having different sigma and mu, and we'll end up different curves. So to summarize what we just said, so the mean mu can be any numeric value, negative, 0, positive, but they are affecting the location of my curve. And then for the sigma, sigma is the standard deviation, determine the width or the flatness of the curve. So the larger value will result in the widened and the flatter curve. So now you know how to using the value sigma and mu to distinguish your normal distribution. And then the next characteristic for the normal distribution is the area under the whole curve. So the area under the whole curve. So one thing I want to point out, some students say, oh, this is 1, this is 1. No, that's wrong. So for the normal distribution, the upper limit is positive infinite. The lower limit is negative infinite. It can be extending as long as you can, but sometimes it's so little, so the area is so small, you might not be able to really see it. But actually, it's going to be extending as far as you can, So the area under this whole curve is equal to 1. And since this curve is symmetric, after you draw this vertical line from your peak, the right hand side and the left hand side of your mean, remember this is the mean, right? This is the mean. So this vertical line separate my curve into a symmetric shape. So the right hand side and the left hand side, they are symmetric. Therefore, the area under each side equal to 0.5. Okay, 0.5. So this is the characteristic. And then the last thing I want to point out related to normal distribution is called the standard normal distribution. We mentioned it in chapter 3 when we are trying to find outliers. If you don't remember, you can go back. So we try to look at z-scores. So z-score larger than 3 or small negative 3 will be identified as outliers. So I said the z-score is coming from the standard normal distribution. So z-score follow the standard normal distribution. So what is a standard? So the keyword here is standard normal distribution. So we literally give this normal distribution a name called the standard normal distribution. So when can we call a normal distribution as a standard normal distribution? When mean equal to 0, standard deviation equal to 1. Then that distribution is called a standard normal distribution. So basically mu equal to 0, sigma equal to 1. That is my standard normal distribution. As I said, if we have the standard normal distribution, so the value, the random value will be converted to z. So that's what we call z-score, or z kind of standardize the x value, right? So that is how we convert it. We learned in chapter 3. If you forgot already, please go back to watch the video. So we are using the Excel formula called the standardize to standardize my values. So that's how we standardize our values. So now, Let's look at a example, basically to help you understand later when we move on to the Excel. You should using the diagram to guide you through which Excel format you need to use. So, Pepzone sells auto parts and the supply, including a popular multi-grade motor oil. When the stock of the oil drops to 20 gallons, replenishment order is placed. So the store manager is concerned that the sales are being lost due to stock out while waiting for a replenishment order. Remember, when they need to replenishment. So when the stock of oil drops to 20 gallons, so drops to 20 gallons. So it has been determined that demand during the replenishment lead time is normally distributed. So the keyword, so now you know this is a normal distribution with mean equal to 15, so mu equal to 15, standard deviation equal to 6, sigma equal to 6. So now we actually know the value mu and sigma. That's the key we need in order to use Excel. And then the manager would like to know the probability of a stock out during replenishment lead time. In other words, what is the probability that the demand during the lead time will exceed 20 gallons? So this is the value we try to, for x, we try to get a probability x larger than 20. So later when we move on to the Excel, you understand that if you're using Excel, you cannot directly calculate x larger or x larger and equal to a value because the Excel can only calculate x smaller or x smaller equal to a value. So therefore, we need to go through a detour in order to get probably x larger than 20. So how we get x larger than 20, given we will be able to calculate x smaller than a value. So that's what we're going to do is we are using a diagram. Okay, we are using a diagram to guide us to understand what kind of property we can calculate. So on Excel, we will be able to calculate x smaller than a value. So x smaller than the value. So we will be able to get x smaller than the value. So therefore, if you look at here, and so what we have here is we are using the Excel to calculate x smaller than 20. That's what we can use Excel directly to calculate it. So on this normal curve, so the gray shaded area is what we can use Excel to calculate. And then we will get 0.7967, 0.9767. But our goal is try to figure x larger than 20, which is the area shaded by green. But we understand a few minutes ago, we learned the characteristic of normal distribution. That is the area under the whole curve equal to 1. Since we know the area on in the gray area and then the green area plus the gray area equal to 1, therefore the green area equal to 1 minus the gray areas. Therefore we got 0.2033. So that's what I want you to understand. Later when we look at Excel part, you have to use this diagram to guide you through how to figure out probability because the Excel can only calculate x smaller than the value and the rest of the part you have to use in this chart to guide you through to play around to figure out the final answer, okay? So this is 1 minus. So another difficult situation is like here. So we try to get what is the probability that the demand during that time will be less than 20 but more than 10. So basically we try to get probability of x larger than 10, smaller than 20, okay? So this is the probability we try to calculate. On Excel, like I said, we only can calculate x smaller than the value, but now we have x larger than 10 but smaller than 20. How we calculate it? And we need to ask the chart to help us out. So you can see on this diagram, the probability between 10 and 20 is this gray shaded area. So that is the probability we try to get. However, we won't be able to get it directly using Excel. We're actually going to go through several steps. So how we do it. So first, I will show you these two diagrams. So here is 20, okay? And then another one's here. And then here will be, sorry, here is 10. There is a typo, okay? Change it, 10. And here is the 10. So from 10 to 20. So now I can use Excel to calculate probability for x smaller than 10. I also can use Excel to calculate probability x smaller than 20. So smaller than 20 will be this area, smaller than 10 will be this area. So the question is, how are we going to end up this grid area? Think a little bit. Yes, you're right. You actually, if you're using this, the p probably x smaller than 20 minus the probability smaller than 10, and then you actually get this grid area. So that's what we're gonna do. We're gonna using the probability x smaller than upper limit minus the probability smaller than lower limit, and then we will be able to get probability x between these two limits. So the common mistake I saw students make is they are understand you get x smaller than 20, no problem, and then they try to get probably x larger than 10 and then find a difference. That would be a problem because look, if you use x larger than 10, your shaded area will be here, and then this area minus this area will end up the wrong answer. Okay, so this is something you need to pay attention. You're using x smaller than upper limit minus x smaller than lower limit. That is how you get the probability between two values. And I will show you the answer for this case. So you will end up 0.5934. Okay, so now you can log in the D2L and go to this week's attendance check. And again, using the same computer skill 3 file, and then using the data file, or you can just open the empty Excel file, and after you finish them, and make sure to submit to this week's attendance check. And so if you have any question when you work on your homework, and feel free to reach out to me.